Hello, this is Mrs. Ward, and I'm just going to go over example 4 and example 5 in case we don't have enough time to get to them in class, or if I just went too fast while we were in class. So example 4, we're still doing the same thing. We're working with ellipses, and we're trying to find the center, the vertices, and the foci of the ellipse given by the following equation. So what we're going to do, remember, is we're going to have to write it in that standard form where we have the parentheses. So I'm going to have to complete the square for both x and y. So what I like to do is I like to put my x's together. So I'm going to write 16x squared minus 32x. And then I'm going to put my y's together. So plus 25y squared minus 50y. And then I'm going to take that 16 and to sort of get it out of my way for right now, I'm going to put it on the other side. So I'm going to subtract 16 from both sides. And that's going to equal negative 16. Then I want to, inside the parentheses, I want it to have a coefficient of 1. So I want this to be x squared inside here. So I'm going to factor out a 16. I'm going to have x squared minus 2x, and I'm going to put a plus, and I'm going to have some number there. I like to leave a plus there. Remember what's going on? So when I do the y's, I'm going to, again, I want to have a y squared, so I'm going to have to factor out a 25. So this will be minus 2y, again, adding some number. And you'll notice that it does not matter whether I'm adding and subtracting in this spot. This will always be a plus sign. Always, always, always. And then I'm just going to write that minus negative 16 on the other side because I haven't done anything yet. Then to complete the square, remember when I go to complete the square, I look at this x, copy that sign down, take the coefficient, divide that by 2. So this will be 1. 1 squared is going to be 1. That's the number that goes here. But I'm really not just adding 1 to this side. I'm adding 16 times 1. So I've really added 16 to this side, which means I have to go ahead and add 16 to the other side to make that equal. When I go to complete the square for the y's, I'm going to have this 25 out here. Y, copy down that minus sign. Half of 2 is 1. But a negative 1 squared is going to be a positive 1. But I've really added 25 times 1, so I've added 25, which means I'm going to add 25. So when I add negative 16 plus 25, I get 25. Remember, in order for these to be in standard form, this has to be equal to 1. So I'm going to divide by whatever number this is. So in this case, it's 25. So I'm dividing everything by 25. When I do that, I'm going to end up, oh, forgot my squares, squared. So when I do this, I'm going to have x minus 1 squared over, and then we're going to divide both the numerator and denominator by 16, so I'm going to have 25 over 16 plus y minus 1 squared over 1, and that's going to equal 1. So which one's larger, 25/16 or 1? Well, this is going to be the larger one, so a squared is equal to that 25/16, which means a is equal to 5/4. B squared is going to equal 1, which means b is equal to 1. Well, in here, I'm going to go ahead and find c squared. So I'm going to say c squared is equal to a squared minus b squared. And when I do that, I end up with c squared is equal to 9/16. So let's see. C is equal to 3/4. So now I have all my information. So now I'm going to answer the questions. My center is going to be whatever I'm subtracting from the x, whatever I'm subtracting from the y. So my center is going to be 1, 1. My vertices, I'm going to do the major first. The major is with this a, which is the x. So the x coordinate of my center is going to change. So my major vertices are going to be, and I'm adding 5/4 to both. So I'm going to have 9/4, 1, and then subtract 5/4. I'm going to end up with a negative 1/4, 1. My minor vertices are going to be adding or subtracting 1 to the y coordinate. So they're going to be 1, 2, and 1, 0. And then my foci, I'm going to add this 3/4 to the x coordinate. So when I add it to the x coordinate, I'm going to get 7/4, 1. And when I subtract it from the x coordinate, I'm going to get 1/4, let's see, 1/4, 1. And those are my foci. So it doesn't ask me to graph, so I'm not going to graph, but there's all the information. The next one is an application problem. It says the first artificial satellite to orbit the Earth was Sputnik. Its orbit was elliptical with the center of the Earth as one of its foci. So what that means is I have this ellipse, and I'm going to draw it way not to scale. Here's Earth. Its center, the center of the Earth is a foci, and then I'm going to have the other foci over here somewhere. Major minor axes of the orbit have lengths of 13,906 and 13,887 kilometers. Find the apogee and perigee from Earth's center to the satellite. Use these to find the least distance and the greatest distance of the Earth satellite from the Earth's surface. In this orbit, the Earth has a radius of 6,378 kilometers. So, in English, here's my pretty little picture. Here's my center. The major has a length of, so from here to here is going to be 13,906. So from the center to one of the vertices is going to be half of that. So I'm going to take that 13,906 divided by 2, and I end up with 6,953. That happens to be my A. Then the other one that they give me is from here to here, and that ends up being 13,887. So the length from the center to one of them is going to be half of that, and that's going to be 6,943.5, and that's going to be my letter B. Now, what I'm looking for in English is I'm looking for the apogee and the apogee, whatever they are, is going from the center to this. That's going to be the pedigree one, and then the other one is going to be from here to here. Doesn't matter the words, but we're going to use them. So here we go. So in order to do this, I'm dealing with the foci, which means I have to find my C. So C squared is equal to A squared. So I'm going to take that 6,953 squared minus B squared. So I'm going to take that 6,943.5 squared. And when I do that, I end up with C equaling 363.34, which let's just think. Okay, so that's my C. So this is that 363. So the distance from the foci all the way over here is going to be that C plus here to here, which is A. And that's the is going to be that 6,953, which is my A, plus my C. And that's going to be about 7,316, dropping the decimals, kilometers. Now that's from this vertex to the center of the Earth. But I want to know what it is to the surface. So then I'm going to take the radius, which radius, see, obviously not draw the scale. The radius is going to be this part right here, which is from here to here, and that's 6,378. So I'm going to subtract that. And when I subtract that from that 7,316, I get 938 kilometers. And that's going to be my greatest distance from the surface of the Earth to the satellite. Now I'm going to do the same thing, except I'm going to find the shortest distance. So the shortest distance is, here's my A, it's 6,953. But now I want to subtract this C, which is 363.4. And this is my, I'm spelling that wrong. I'm sure I'm spelling that wrong. That's an R. And when I do that, I end up with, I didn't write it down. Why didn't I write it down? I don't know why I didn't write it down. I didn't write it down. I'll get there in a second. So when I did that, and then I got that number, and then I subtracted the surface, 6,378, and I end up with 211 point, well, 212 is what it rounds to about. So this will be 212 kilometers, which is my least distance from the Earth's surface to the satellite. And I'm trying to see if I wrote that other one. Oh, yeah, when I subtract these two, sorry, I got the pedigree is 6590. So that's how you do one with word problems. Again, you're going to have to manipulate your A, your C. I didn't write it in standard form because it didn't ask me to write it in standard form. I don't have to graph it, so I didn't graph it. So I hope these help for the last two, and we will see you next time in class.